Yeah, hello, welcome once again to our lecture. So we'll continue from our previous lecture we had on matrices. So we defined what a matrix is in our previous lecture. Then we did a little algebra and a matrix. So we looked at addition and scalar multiplication of matrices. So today we'll be discussing multiplication of two matrices. We'll talk about transpose and inner products. So we are saying if we have two matrices A and B, the two can only be multiplied if the number of columns in the first matrix, say A, is equal to the number of rows in the second matrix, say what, B. So what it means is I have a matrix A, this is the matrix A, and this is the matrix B. I can only multiply these two matrices if the number of columns here is equal to the number of rows here. So let's look at the matrix A. How many columns do we have? We have 1, 2, and 3. So 3 columns. How many rows for the second matrix B? 1, 2, 3. So you realize that the number of columns here is equal to the number of rows here. Meaning these two matrices, we can find the products. So how do we go about it? So this is our matrix A and this is our matrix B. So if we want to find the products of the matrix to get the individual elements or entities at its rightful location, this is how you go about it. So you pick the first row of the first matrix A and you multiply by the row, the first row of the second matrix. So I have this row and this column. So I do the product on it. So I multiply this times that plus this times this plus this times that. So that becomes my first entry. So that is what you have here. Then you come to the second row. So you pick the second row, then you multiply by the first row. So this has the first column. So the second row in the first column. So this has just one column. So we pick this and we multiply by that. Let's take an example. So I have this matrix A and B. Let's check how many columns do we have. We have 1, 2 in the first matrix, and how many rows? 1, 2. It means that we can do matrix multiplication on these two matrices. So how do we go about it? Okay, so it says I pick my first row and multiply by the first column. That becomes my first entry for row 1, column 1. Okay, so let's do that and see. So first row, first column. So I pick 1 times 8 plus 5 times 2. So 1 times 8 plus 5 times 2. That is my first row, first column. Then my first row, second column is what? So you pick the row again, then you multiply by the second column. Then you do the same thing for the third and fourth. So that will be for the first row. Then you come to the second row and you do the same on each column. So if you pick the third row, you realize that the third row on each column, you have 3 times 8 plus 4 times 2. That's for the first entry, 3, 1. Then 3, 2, the second entry is going to be 3 times 4, 3 times 4 plus 4 times 5. That is what I have here. That is the second entry. That is 3, 2. Then the third entry, which is 3, 3, is going to be what? 3 times 3, 3 times 3 plus 4 times what? 8. Then my last element, I have what? 3 what? 3, 4. So what do I have? 3 times 1 plus 4 times what? 6. So I have this. So now let's simplify. So 1 times 8 will give you 8 plus 10 here. So 1 times 4, 4 plus 5 times 5. So you do the same thing for the first row and the second row. If you look at the third row too, you have 3 times 8, which is 24 plus 8. Then 4 times 2, so 24 plus 8. Then 3 times 4, 12. 4 times 5 is 20. Then you do this, you get that. So if you simplify, this is the matrix, the products of the two matrices A and B. So let's look at, initially we had what is the order of this? If you remember, we are saying the row and the column. So this is what? 1, 2, 3. So 3 times what? 2. And this is what? 2 times what? 3. Okay, so we are saying that if I have a product of an L times M and an M times N, so the number of columns should be equal to the number of rows, then the product is going to be of order what? The number of rows in the first matrix by the number of columns in the second what? Matrix. So we have order of what? L times M. So if you look at the number of rows we had in the first matrix, how many rows did we have? We had 3. So 1, 2, 3, 4, the first what? Matrix. Then how many columns did we have for the second matrix? That is 1, 2, 3, 4. So the product of these two matrices was going to be what? 3 by what? 4. Now let's look at it here. So you realize that we have how many rows? 1, 2, 3. How many columns? 1, 2, 3, 4. So this matrix is of order what? 3 by what? 4. Very good. So you can write your own matrix and make sure that, you follow the number of columns being equal to the number of rows. Then you can do the matrix multiplication on that. Okay, so if I have two matrices A and B, so if I multiply A and B, will it be equal to B and A? B and A, you should check that and see if it will be equal to. Then you let me know, and you can leave your comments on that under the comment section. So if the matrix A is of order M times P and the matrix B is of order P times N, it means that we can find the product of these two matrices. Why? Because you realize that the number of columns here is equal to the number of rows here. So we are saying then AB exists. So the order of AB is now going to be what? M by what? N. So that is what we have here. So in order for BA to be identified, so the previous question I asked, if I have AB is equal to AB, BA. So in order for BA also to be defined, then we are saying that M should be equal to what? N. It means that the number of rows here should also be equal to the number of what? Columns what? Here. So then A is going to be what? N times P, and AB is now going to be what? N times N, and BA will be of order what? P times what? P, because M and N are what? Equal. So then we are saying that AB, BA, if you look at it, AB and BA, they are what? Square matrices. Yeah, square matrices. So you can see that from here, N by N, P by P. Okay. For AB, BA to be square matrices of the same order, means that what P is what equal to N, like we showed here. So for AB to be equal to BA, this is what we are saying. Then it means that initially A and B are all square matrices. So if I find the product of two square matrices, then I'm getting AB, which is going to be a what? A square matrix. And if I find BA, it's also going to be what? A square what? Matrix. So we are saying for AB to be commutative, for AB to be commutative, for AB to be commutative, AB, BA must what? Exist. We know the property of commutativity, which is AB is what equal to what? BA. So for A to be commutative, we are saying that then the matrix must be square matrices of the same what? Order. Of the same order. So you can write two matrices of the same order and you can verify if they are what? Equal. I'll kindly wait for your submissions and your interesting results as well under the comment section. So if I have another matrix, so you're looking at the inner product. So let's say I have two matrices. I have the row and then what? Column matrix. A row and what? A column what? Matrix. So I have A to be of order m times n and B to be of order p times n. Then the product AB is equal to what? C is of order n times n and is given by this. Okay, so if I have a product, okay, so I have a row and a column with matrix. Is the summation. We are saying that C is just what? An element. It's just going to be a single what? Number, because we are going to take the summation of the row by the column matrix. So I have this multiplied by this plus the first row, second column multiplied by this plus the next till the last number you have. So we are saying that where the AJ's represent the AI row of AB, and this represents the jth column of B, and the BJI's represents the I plus jth elements in what? C. So that is what I was explaining here. So this plus that, this plus that. So at the end of the day, if it's just a row and column, the product is just going to give you what? A single what? Number. Okay, so this is a row vector or a row matrix. Then this is what? A column. If I take the product A times B, what do I get? I just get a single number, which is what? A 1 times 1 matrix. Okay, so we want to look at the other types of matrices you would see. So we have what we call the unit or identity matrix. So we are saying a unit or identity matrix is a diagonal matrix with all the elements in the principal diagonal equal to what? 1. So normally you represent identity or unit matrix by what? I. We are saying for any other matrix A, then the following relationship exists. If I multiply the matrix A by the identity, I still get my what? Matrix A. If I multiply the identity by the matrix, I still get my what? A. So this is the property we are talking about, the identity property. So this is what the identity matrix or unit matrix. So this is what? A 2 by 2 matrix. So we are saying that the principal diagonal is what we are seeing here. So this is the principal diagonal. So all the elements in the principal diagonal, it's equal to what? 1. So this then becomes what? An identity matrix. If I take this matrix as well, this is what? 4 by 4 matrix. You realize that the principal diagonal. So this is the principal diagonal. And the elements there is what? 1. Okay. So an example. So take any arbitrary matrix A and multiply by the identity element. So you realize that, so this is for the first entry, I have to multiply the first row by the column here. So I have 1 times 1 plus 2 times 0 plus 3 times 0, which will be 1. So that is what you have here. You do the same thing for each column. Let me take the third row here by this column. So I have 2 times 1 plus 5 times 0, 6 times 0, I have 2. If I come to the second, I have 2 times 0 plus 5 times 1 plus 6 times 0. Then you do the same thing for the third row, and you realize that you are going to get what? The same matrix back. Then you have the 0, or what we also call the null matrix. We are saying it is any matrix in which all the elements have 0 values. So it is denoted as this. So this is what? A 0 matrix. Okay. Transpose. If I have a matrix A of order m times n, then the transpose of A, denoted A exponent t, is given by A exponent t. So you take the transpose here of that. So what happens is, so this is the order m by n. If I transpose, what happens is that I change columns with what? Rows. So this is what it means here. So if I take the transpose, the I, which is the row column, becomes the j. The I, which is the row, becomes j. Then j becomes what? I. So we are saying ith row of A has same entries as ith column of 8, the transpose. So let's look at this matrix A. So we are saying if I have a matrix A and I want to find the transpose, all the rows are converted to what? Columns. So I take the first row and it becomes my what? First column. Then I pick the second row and that becomes what? My second what? Column. So what do I have now? So you realize that this is my first row. It now becomes what's my first column. My second row becomes my what? Second what? Column. What is the order of this matrix? This is what? 2 by what? 3. This is what? 3 by what? 2. So the order changes for a transpose. So if the matrix is of order m times n, then the transpose of that matrix is going to be what? N times m. Okay. So we are saying that if I have the matrix A and I take the transpose of that matrix, then I transpose the matrix back, I'm going to get what? The original what? Matrix. So let's say with this example, this is the initial matrix. If I transpose the matrix, this is what I get. Okay,